Okay, hi, I'm Veena, co-founder and CTO at NeuroRehabVR, and I'll introduce a little bit about what we do and how we are starting to implement AI and virtual avatars into the dynamic environments that we're creating for physical rehab. And we started to do this because my co-founder's son had a brain injury about 3 years ago, and he wanted the best for his son. And that's why he started to be very technology forward. We bought a robotic system to help him walk again because he's 6'3", and it's really hard for a therapist to make him walk, support him and make him walk. So we bought a robotic system that will do it for him and also do it with the right gait. During the presentation, you'll figure out how gait training is one of the most important parts of physical therapy, especially for somebody who had a stroke or a brain injury and they're trying to relearn how to walk again. So we bought this robotic system, and then it's going well, and now he looks at VR, and that's where I come in. My expertise in virtual reality and medical simulation, and we started to work together in the clinic, and that's how NeuroRehabVR came about. Is it this? Okay. Slides work sometimes when you're doing VR. Each year, more than 800,000 people suffer from a stroke, and more than 60,000 are diagnosed with Parkinson's, and 1.4 million people suffer from a traumatic brain injury. So there's tons of people who, all of this leading to some kind of long-term disability who need physical therapy. And most of the time, the brain is affected. So when you're doing physical therapy, traditionally, they forget about the brain itself, and they're concentrating so much on your movement and more on your physical therapy and how to move your hands or legs or things like that. So what we are trying to do here is combine the part of your cognitive and physical therapy together. So you need to go so that they go hand in hand, and you're working on both of them together. And we implement neuroplasticity a lot in what we create because we know it has been shown that the brain is very plastic, which means if you have damaged areas in your brain, it is still, your brain can relearn those functions that you lost with forming new neural pathways. And this is where the healthy parts of your brain can take over the functionalities of the damaged areas. And it's shown with physical therapy and cognitive training, there is a chance for a lot of people to recover to an optimal level. But as you said, physical therapy can be expensive. Clinics are usually far and apart, so transportation is a problem for most of these people. And on most days, they're too depressed to get out of bed and actually go to therapy. And when they do get to therapy, they find it really boring and repetitive, and nobody wants to do it. And that's why we started to create these virtual reality. Let's go back one. Oh, no. Can you play the video? Okay, that's why we started to create these VR applications that target different parts of your body and the brain. So you could be working on your shoulder therapy or your gait training. We have applications depending on the patient diagnosis and what they're working on. And the physical therapists are our biggest advantage, and having them around, they're able to take the tools that we create and use them in ways that we would have never thought about. And that's been working out really well for them, for us and for them, and for the patients too. Now I'll go a little bit into the data analytics part of the piece of this, dynamic virtual environments, and also AI-driven avatars and training in VR, and how all of this comes about to what we are doing. Okay, so data collection and analysis is becoming more and more important in the medical field, especially we recently did a survey for NSF where we spoke to therapists and patients, and three big things came about. One, patient outcomes. Every patient is unsatisfied about the outcomes they get from therapy or even going to a hospital. So I thought that would be a good picture to show how us dealing with healthcare feels like. So unsatisfactory patient outcomes, cost of high care, all of us know about this. And then in our case, once patients go back home, therapists send them a little list of, these are all the exercises that you have to do at home before you come back to therapy tomorrow, and they never get it done. So patient compliance is really, really low because the exercises are very boring to do. And then, especially when, again, that comes down to even pills, people don't go back and take their pills sometimes. And limited insurance. And the biggest part for data analytics and collection is the reimbursement models for insurance are changing right now. At first, hospitals and clinics were paid for the volume of visits they got, but now it's changing to, it depends on the patient experience, the data that they're coming out, are they progressing or not? So insurance is doubling down on that, and they want progress reports. So everybody is trying to add, instead of adding qualitative notes like, they got better, you have to show them by how much they get better. So data analytics and collection is becoming a big important thing. So, and also from the consumer side, people don't want to just wake up, survive, and sleep. Now they want to know what's happening with their body. They want to keep track and how they can do better and get better, and also know what's going into their body and what the doctors or patients, the doctors are prescribing to them. So for us, we collect data such as range of motion, joint angles, your velocity and acceleration, which is correlated to your strength, response times inside the VR environment. Are you focused or are you distracted while you're doing your therapy? So with all of this data, we can quantitatively show the patient if they're making progress or not. And when it comes to walking, there are a lot of exoskeletons, devices out there which help the patient walk. This can't be a state model where there's one input, there's an output. That doesn't really work for everybody because everybody's walking gait is different. So here AI is making it more intuitive where if you're having a toe drag, the machine can then correct for that instead of correcting you for something else. So trying to figure out according to the patient and personalizing the treatment is very important. And sometimes patients have improvements, but they cannot really see it, and the therapist can't either. So having quantitative data, we can show those subtle improvements that you're having, which will keep the patient engaged and encouraged to keep going to get better too. And the biggest thing that that has happened in the last few years is electronic health records. Because of electronic health records, even though it's very sparse and it's at different places right now, if you get all of that together, we have tons and tons of data that we're able to predict. Depending on a patient diagnosis and historic data, we can predict what would happen to the recovery process of another patient or somebody else, or predict, we can give them recommendations to what they have to do to get to their optimal recovery process. So that's data collection. And I've seen therapists are really good at figuring out a person's gait. Like the other big thing that came about when we did our NSF survey was people just wanted to walk. They're like, I just want to learn to walk again. That's about it, which just seems like really easy for us here, like able-bodied people, but when you're trying to walk again, it's really hard. There are so many gait mechanics that are involved in it. One, you could do a lot of toe drag, or you could have heel drag, or your pelvic flexion and extension is not right. The therapists, as they are experienced, they're really good at figuring out what part is going on, but they still can't identify it as better as what a machine could do. So that would be a really good way to figure out if the patient is getting better or not. So now going to dynamic virtual environments. How many of you are game developers here or know about Unity game engine? Okay, one person. Okay. So Unity is the game engine that most game developers use to create games and virtual environments. The biggest problem that game developers have to deal with is, you could end up making the game really easy or too hard, and nobody wants to play it again. You have to keep it compelled enough that they keep coming back to your game, and that's one of the hardest things to do. Other than the part, it's really hard to create a game itself because you have to build the virtual environment, you have to build the interaction between the player and the environment, and a lot of other things that go into it. So for gamers, if it's too easy, they don't want to play. If it's too hard, they get frustrated and they stop playing the game. And then there's the rage quit, where they're really frustrated and they're done. But when you add patients into that, especially our patients who are mostly stroke or traumatic brain injury or spinal cord injury patients, we are creating games and environments such that they don't feel like they're doing therapy, because we don't want to recreate something that they already do in therapy, like take this little block and put it here, it's boring. We want to create things that they would do in everyday living scenario, like maybe grocery shopping, and put that into a virtual one, keep it controlled so that we can also figure out if they're getting better or not, and also give them quantifiable data, and use intelligent dynamic environments. to do that. So the challenges just keep going up for when you're dealing with patients. And then depending on the diagnosis, there's a saying that when you've seen one brain injury, you've only seen one brain injury because they're so different from each other. It depends on which part of your brain got affected. It could be, your speech was affected, or it could be one part of your side was affected. So there's that. And then again, if you're emotionally unstable, you could get really discouraged if you're not able to actually get to a goal in the game, and that's very depressing for patients. So we have to make sure that whatever we create is they're always challenged, but they're never discouraged from finishing the goal or the game that we set for them. One of the ways that we do that is we collect range of motion data, like I said. So if somebody's going through grocery shopping experience where they're trying to pick up items off a shelf. And depending on the patient diagnosis, some patients can only move their hands so much, some can do more. That's the whole range of patients that we have. The ones that can only move their hands so much, if they're not able to get to this item that's right there and they get really frustrated, they're like, I really want that burger, but I can't get it. And it's a virtual burger, it should not be so hard. So what we do is we make the game environment easier for them so that the burger starts to come towards them like a Jedi Knight. Now they feel like a Jedi Knight. And they're not discouraged, and it's still challenging. So that's kind of how we've started to include dynamic virtual environments. And so that the game changes depending on their performance and diagnosis. Here's a little video of how that works. You can see that little sandwich. She's just holding her hand there and it's coming to her. If you didn't get that, so if you look at the sandwich, it's slowly coming towards the hand there. So now going into AI-driven virtual avatars. There's something called NPCs, which are non-player characters. If you've played any mass multiplayer online games, there are virtual avatars that speak to you in different parts, and conversational AI. So instead of having a state model, just like I said, how it was always hand-coded in games, where you have this input, where you go to the character, the character says the same thing over and over again, and you don't really get any, it can be randomized a little bit, but it's never gotten to the point where it responds to you according to what you say to a conversational AI character, and also with non-player characters and interactions with them. So what we started to do was, with our environments, we're starting to add AI with neural networks, where we have an environment. This is for patients who have pain and anxiety and they're trying to calm down in the virtual environment. We have little animals that you can interact with. So with neural networks, what we can do is, we can make the animals respond exactly how they would in real life. So they have behaviors of eating, sleeping, flocking, wandering, and also running, and it's all weighted on normal behaviors. So if you're in the virtual environment and you're agitated and you try to go pet a deer, it'll run away. But then if you're calm and you go near it, it'll let you pet it. And if you get fish, you can, in one of our virtual environments, you can go boating and fish, and you can bring back the fish and give it to a bear. So with this, what we're able to do is we're trying to create empathy. We're trying to create things such that, the person who's emotionally unstable, or you need emotional behavioral therapy, you can kind of do that in the virtual world, and which will also help with them when they're out of the virtual world and dealing with their friends and family in real life, forming that empathy. And now you're recognizing the behaviors that you have in a controlled environment, so you can correct them with virtual animals and stuff, because people are more open to virtual avatars and animals than they are with real therapists. And that's kind of the study. There's another study that says that. So this is how we're kind of using virtual avatars and in our environments. There's a little demo here. This was created to figure out how people do in social situations. Like if you're in a lunch line, if your kid's on an autism spectrum, what if the bully comes by and asks you for your lunch? What would you do in this scenario? And we're trying to train kids to how to respond to these situations, or see what they respond and then maybe correct their behavior. I hope you can hear this. Is the sound on? Okay, try that again. I'll just say what he's like, hey, give me your food or I'll beat you up. That's exactly what he says. So now you can either give him your food, or we have, that didn't get into a screenshot, but it says you can give him the food or you cannot give him food, and then depending on what you respond, he responds according to that. But we are making this more intelligent as we go. So like I said, we use Unity a lot for everything that we create, and Unity is coming out to different machine learning toolkits that you can use if you're interested in it. This will give you a little demo of what you can do with Unity and machine learning now.
I'm interested in how learning, thinking, understanding, reasoning happens. Machine learning is a place where people are trying to figure out how to get it to happen in computers, which was kind of inherently interesting to me. So in the case of something like a self-driving car, what you need is complex environments where there are lots of realistic physical interactions. And that's why we need richer training environments. Games are becoming more and more realistic. So Unity as a game engine is kind of perfectly positioned to provide what people in the research field need. There's a lot that machine learning can offer to games themselves. If you start to think about personalizing an experience in a game, this is something that machine learning could make possible. And now, kind of with all of these more and more complex algorithms, we're starting to think about ways in which these algorithms can then be applied back to the games themselves. So the two problems that game developers face when they're trying to design a game is that the game either becomes too easy and players get bored with it and stop playing, or that in later levels, or even from the beginning perhaps, a game is too difficult and players simply quit because of that. Praneet is an intern that we had work with us in the machine learning team over the summer. What he's been working on is kind of taking the platform that we're developing and trying to use it in kind of more specific ways that can actually help provide more interesting games for players.
So when I started my internship here, Author and me discussed what game we could actually work on, and we both came to a conclusion that Tanks, which is a Unity environment, would be suitable for our task to test out our algorithms. What if we have a superhuman AI agent and actually allow him to adaptively change his level of skill based on the way in which you play? It's a much more personalized experience for them, that you keep on matching their difficulty at every point of time, so you can get a more personalized experience. I feel that's really cool.
Unlike perhaps older fields from a few decades ago, the machine learning community is very open in terms of sharing ideas, sharing code, sharing work. So we think it's a natural fit to kind of continue this trend of releasing tools that are open, that anyone can use, and inviting open collaboration. And that's why we're so excited to be releasing an initial preview of this product.
So all of these tools are really new, so if you would like to learn about it, you can just Google Unity machine learning and you'll be able to find it. They're always adding new things to it. And what you saw in the beginning was training AI in a virtual world. Because all of these engines are physics-based, you can recreate a real-world scenario really easily in a virtual world and let the robot train. So this is a little example of how this Isaac robot was trained to play dominoes in the virtual world. And I think it was last year, SIGGRAPH, you could actually, on the other end, you can play, after that it was connected to the actual robot and you could play dominoes with it. So with this, one, it takes the cost and risk of training a robot using machine learning in the real world, and then it could make potential mistakes and damage itself or the real world environment. But now inside a virtual world, it can explore and learn through trial and error using different training models, and then take those same parameters and connect them to the real world. And especially if it's a robot that's playing with an actual human, you're taking out the risk where you wouldn't want to put a robot that's still learning how to play dominoes in front of a human. And that's how training in VR is done. Here's a physics-based model where this Ragdoll was a physics-based Ragdoll, and it was unsupervised learning, where it was told to learn how to move forward in space, not exactly walk, but just move forward. It learned it in a really funny way. funny way of doing it. But then going back to us, with physical therapy, what we can do is once we figure out what the exact gait model is for a patient, we can take that model and then always compare them to the progress that they're making to show them exactly where they need to correct their gait. And that's kind of what we're thinking of using this kind of training model for. Okay. And just to talk about a little bit of how the training models work in VR, they're usually an AI agent that changes the state transition between the action that it's created, changes the state of the environment. But this is how it's usually done. But how with Unity progressing, you can have different AI agents that are connected to different brains. But with those brains are the ones that are you can connect it to TensorFlow so that you have your models in TensorFlow, or you could have the AI agent changing its action depending on what the player does, or you could just have a hand-coded behavior, and now you'll be able to simultaneously figure out which one is the best for your agent. And those are things that you can do with the new upcoming Unity AI toolkits. Here's a very small, I'll just skip the reinforcement demo. I'm sure you've seen a lot of reinforcement game demos, but here's a little one about how our therapist.
So Deidre's here working on the game Foul Play. What we're trying to accomplish her with this game is her sequencing and purposeful coordination of her movements. We're also working on her dynamic standing balance, her weight shifting abilities, range of motion throughout her legs, as well as improving trunk mobility. Lots of good things going on with this game for her.
So right now, the therapist can dynamically change the difficulty of the game depending on how they're doing. But again, as we move forward, we will dynamically change it through the environment so the therapist can focus on the patient. Thank you. That's about what I have.
So I think we have time. Oh, this mic's not working. So we have time for one question. I'm going to ask it. Oh, you have another mic. Okay, maybe two. So my question is, how long has your facility, NeuroRehab, been open? What has been have you quantified the success rate so far? That would be really, because this is the future of rehab.
Yeah, I do not have my slide for that, but we've been doing this for 2 years now, and we've seen a few quantifiable results where once they put on the virtual, if they're working on gait training, they put on the VR headset, they have a goal now. They have to, it's like you pick up 100 coins in 60 seconds. Now they're really motivated, we've seen. So that makes them go harder. So, and also cardiopulmonary efficiency, because now people like what they're doing. They stay in conjugative therapy for longer, which is increasing their stamina. And for our patients who have cerebral ataxia or brain injury, their hand-eye coordination is getting better, which translates to their real-world environment at home, picking up objects or doing tasks.
Fantastic stuff. Thank you very much, Veena.